Thank you very much indeed. It is a huge honor to be able to present today at GoLab to an absolutely packed room. Thanks so much, everybody, for coming in to listen to something that's a little bit different from the regular background of Go development. Now, I'm assuming everybody in the room has a little bit of knowledge about Go, or they already know why it's an exciting language. But I want to talk to you about how this can apply to building graphical applications, and literally how I get on a regular basis this feeling of joy to be able to build something so simply across all platforms using a language that is just actually such a good fit for it. And of course, how can we not be really excited about it with such a great mascot as well? But before I jump in, a little bit about myself. I haven't met a lot of you before, so it's a really fantastic time to be here, and maybe I'll talk to some of you later on. You may have encountered me online. I go by andy.xyz on a number of usually fine specific rooms on the various socials. I am, by background, a software engineer. I have written some books on Go. I like to think of myself as a tech leader. I've recruited teams, grown businesses around software development, and in my other time, being an open source advocate, I think, again, Go is really showing us well the benefit of an open source approach to development, but I think we can take it into just about everything we do. Background in the area of graphical applications and toolkits. I've been a core developer on Enlightenment before, the Enlightenment Foundation libraries, which people might have heard about. There's an entire Linux stack built on top of that stuff. And in terms of developer tooling, I was part of the Maven project around Maven 2 release for a couple of years as well. And 5 years ago, or more now, I think I'm losing count, I started the Fine project, which was a very exciting point for me because only a week later, I learned about the Go programming language. And so I did, in fact, start the project before I learned any Go. And this is why I have the confidence to say that Go is a fantastic fit for what I'm doing, because I started the project and then found the programming language that fitted. And my day job, because those things don't keep me busy enough, is that I'm running Fine Labs, which is a company that is out there trying to help businesses get more out of the technologies around Fine, grow the community, and help to support all of the work that the amazing people are doing in this area. Also, this is me, just for a little bit of random background. I quite like trains. Yep, that's me happily in my garden. I quite like a bit of music as well. I think this was the music of Zelda with a live orchestra in London, and quite a fan of sci-fi. So I hope that in amongst there's something that we can all associate with. But at this point, I think it's expected that I would use ChatGPT or DALL-E to generate some kind of image that combines all of these things together. But I don't have to. You can see all of these things happening all together in Disneyland. It's my happy place. Now, there is actually a segue here, tenuous though it might be. What does Disneyland have to do with open source development and programming? Well, if you have been there and experienced it, you'll know what the impact is when you walk into a place where the cast members are all working together to a common goal. They're trying to make a place fantastic for all of the people that visit. And that, I think, matches up really well with an open source community, particularly the Go community. I've never worked somewhere before with such a welcoming group of people who are trying to make sure that everybody has a great experience. So thumbs up, I think Cameron said earlier, but this place is made by everybody here and everybody in the community, so thanks for that. Now, moving on to graphical apps and a bit of background for user interfaces. I don't know how many people recognize this. Don't worry, I'm not going to ask for a show of hands. It probably says more about age than enthusiasm. But this is a screenshot of the star system, which was built on the Alto system, the hardware, from Xerox PARC back in the 70s. There's a lot of similarities there, and things have thankfully come a long way. But unfortunately, they also haven't actually come that far. Over the 10 years that followed, there was a change in programming language from Smalltalk and Lisp to standardize on C. And actually, that's where a lot of stuff remains. They love to think about memory management and which thread they're using. And apparently, because these things were built before it actually mattered, a web service wasn't all that important. Strings were perhaps a new concept, and what even was Unicode? This isn't really an amazing place to build modern software on top of. Some people have tried. There are modern connections to systems like this. I think there's plenty of well-respected projects that maintain a Go binding to existing technologies. But these, unfortunately, being not idiomatic, not necessarily set up the way that we would expect to learn, do have a little bit of a barrier to entry. The toolkits, because of their age and complexity, they can be quite massive. Well, just not, I think, the fantastic way to get into it. There are modern alternatives. If you've seen what Google and Apple particularly have done in this area, it's very exciting, but they're only for specific platforms. Hopefully all of that doesn't resonate at all. We don't work that way. Go just does away with all of that for us. We have a fantastic place where we can write code just once, and it's going to build for anything. All of the applications that we write are going to run on any platform. These are static or near enough binaries that are relocatable and have no runtime dependencies at all, which is great for developers and for end users alike. We've got native performance on all platforms, and we get unit testing, documentation, and all of the fantastic things that come with a modern programming language, which I think leads to a much lower barrier of entry so that anybody can get started and actually code up something really quickly without a huge amount of background experience. So that's the background on why I felt that there was an opportunity to build something new. And that is where Find comes in. It brings a new hope for app developers. Now, I hope you'll excuse, I've got a few images in here that I think brighten up the section divides. I want to say they're all gophers. I'm actually no expert. They may be all sorts of different types of wild dog things. This one I know is. He's my friend Gophie. I'm sure that you all have one like him, and I know there was versions of them being handed out earlier as well. But why a new open source toolkit? Well, basically to overcome all of the things that I presented earlier. It's a fresh start, something that is easy to understand and get started right away. Something that people can contribute to without having to have a huge background in legacy technologies or knowing why things are the way that they are. We can build platform-independent native apps. And that statement is true. People have told me you can't, it's impossible. Well, I mean, it's not impossible anymore. Maybe it was before. Maybe that's why I got excited about the opportunity. We can deliver lightweight applications with great performance. I mean, it's a different way of saying the same thing, but the benefit is pretty great. But also, we can drive something from the community. When you spend so much time around the Go community and work with people, you realize that if you can involve everybody, they're going to help to provide thoughts, direction, contributions. And if we can wrap this up in one, then that's fantastic. If we can prioritize based on what everybody wants, then we're building the right thing. And so that's fine in a nutshell, basically. It aims to be the simplest toolkit for developing beautiful, user-friendly, graphical applications that run natively on desktop, mobile, and beyond. If you've not heard of it before, that's fine. If you have, I hope that you're enjoying it. There are lots of different toolkits out there. I don't want to show anything in particular about this slide except for the fact that all of them are going pretty fast. Somehow we're managing to do so quicker than a lot of others. And in the last couple of months, we celebrated 20,000 GitHub stars and then 21,000. And I mean, perhaps just myself, 21 and a half. Seemed like a fun number to be celebrating. And because we're building on top of the Go toolchain, Find applications are going to work on pretty much every desktop computer. Even if you like BSD, you're not going to be left out. I can't honestly say I've tested it on Plan 9 recently. I'm not sure that it's famous for its desktop experience. Mobile devices there. We go back, I think it's about 6 years in terms of our mobile support, which is more than the commercial providers of these platforms actually do. In fact, we only had to take out 32-bit iOS support recently because the Go compiler toolchain said that wasn't actually going to be useful to anybody anymore. So we recently moved off Go 1.14 as our lowest supported platform. We're in the browser as well. It's not 100% there. There's a couple of gaps in the implementation, so we don't encourage people to use it yet, but if you would like to see it running, we're compiling to WebAssembly, cross-compiling using Gopher.js to a JavaScript runtime, and the web-generated content is going to pick the best one for the browser it finds at runtime. And incredibly, also on embedded devices. There's literally industrial hardware out there with a 2-inch screen and 5 buttons in hardware that is running fine applications. They don't have an OpenGL backend, but they're using the same technology to render through a frame buffer that they control. So the possibilities are kind of endless. That's enough talk, enough of the why. I don't know if this is a gopher, but he's going to show you how to build your first app in just minutes. There are some prerequisites. Because this is not pure Go all the way down, like I said, we've got some OpenGL. We need C at the back end to connect to a graphics driver, which means, unfortunately, you will need a C compiler installed. Now, if you're on Mac, you might have it through Xcode. If you're on Linux, you've probably got a C compiler installed already. If you are on Windows, that might be a little challenge. It's not a phenomenal development environment. Visual Studio is. Windows, not so much. I would recommend MSys2 and the Ming W64 project if you're working in that space. And if you're looking to code onto mobile, for iOS, you will need the Xcode platform set up and to be running on a Mac because of their licensing restrictions. And for Android, you would need the SDK and NDK. If you want to compile them natively on your computer, there's alternatives, which I'll come back to shortly. But we're coding our first app. So apologies for anybody that heard me ranting about this earlier, but we have to make a directory. We have to set up a Go module, and then we need to get the dependency for fine into the system. And we are then going to code our first little bit of a graphical user interface in UI.go. I'm going to chicken out of coding this directly. The full listing of your first application is on screen here. It's a fairly standard hello world. We call package main because we're going to build an executable. We're importing the app and widget packages. The app package is going to do everything that we need it to in the compiler toolchain, also at runtime, to understand the device we're running on, to wire everything together so that your application is just going to work. We then open a window from this application. We title it hello. For platforms that have a title bar, you'll see hello written there. For others, it might not be visible. But the important part there, the one-liner that really is our entire application, is to say the window content should be a new label. The label will say, hello fine. And then we will simply show the window and run the application. You don't have to show the window when the application starts. You don't have to limit it to one window. But this is hello world. Possibly, nobody's going to be getting any prizes to imagine what this piece of software does. But we will go back to our command line. We'll run go-mod-tidy just to make sure that everything's in place and downloaded. And then we will go run this app. And that's what you'll see. Assuming that your computer is running on dark mode, that's what you'll see. If you have a light mode configuration, it will be approximately the inverse, something that fits with the color scheme of your laptop. And that is going to fit into the aesthetic as well. So the text size, the scaling is all going to fit into the configuration that you have running on your platform. It wouldn't be much of a talk if I just left it at and said, isn't it amazing? So let's build something a little bit larger and see whether or not the complexity increases hugely. So I'm going to use, as an example, a Markdown editor. For our layout, there's going to be an entry, an input field on the left-hand side where we just type raw, ASCII, Markdown. And on the right-hand side, we're going to use the rich text widget. Thankfully, this understands Markdown, which is a real helper to us, but it's going to render it directly. And around the application, we're going to use a container called Adaptive Grid. So the one thing to know about fine applications is that the containers control how big things are on screen. It lays things out from the widest area possible down to the details of the widgets. If there's one thing that you're going to need to learn when you're picking up this framework, it's that we decided that widgets determining how big they should be is one of the things that gets in the way of building portable software. Your screen could be a 4K resolution output on a desktop. It could be a couple of inches across on a small mobile device. We don't want single items to determine how big the application should be, how the interaction is going to work. So it works in the other direction. You put things into containers, and the containers determine layout and size, whether things are even visible in the particular window or form factor that has been chosen. And I'll leave that there right now. It's the one kind of change that we made to how things work conceptually. And I don't say this for myself, but from people I've heard on Discord, once you get it, it's amazing. You might not get it first time. We're also going to wire those two things together to complete the interactivity of our application. The entry widget has a callback field that you can set called onChanged. This gets triggered every time the content of the entry changes. And the rich text has a function called parse markdown, because like I said, rich text understands markdown to take input. And thankfully, those both are a function that takes a string as a parameter. So we can get this entire markdown editor in 3 more lines of code than hello world. So I'll not tell you why we need a different title of our window, that's pretty obvious. But the 3 lines of code in the center are really important here. So we make a new multi-line entry. That's our entry that the input we're calling edit. The output I'm calling preview. You could just say new rich text, but for clarity, I called new rich text with markdown, from markdown, with an empty string. It's going to show you nothing, but it sort of shows the intent. And then the magic line that wires it all together is edit.onChanged equals preview.parseMarkdown. And so when the editor changes, the markdown will update its rendering. And the last line of relevance there is the container that's being used to assemble it together. We're saying use an adaptive grid with 2 columns or rows, and then put the editor first and the preview second. I didn't really explain what adaptive grid is. It's essentially a standard grid, lays out along a row, along the columns along a row, and then goes to a new row if needed. But if it's in a form factor where things are portrait instead of landscape, which I think is the norm, then it's going to row them out in rows in a column first, which will make sense in a moment. So it's adapting to the interface orientation. We run that code, and we have a markdown editor. This literally is the code that I just showed you. I don't know how many people have tried to make a markdown editor before. This gives me a little tingle. So few lines of code makes a useful application. It's one that I've used a number of times, actually. But I can see that you're not impressed by being able to build a desktop application in that way. Well, that's understandable. But I then ran the same code with some slightly different parameters and installed it onto my iPhone simulator. That's exactly the same code running on iOS. I've used it to edit some slightly different content, but it's the same runtime, the same code that was used to generate it. And then I rotated my simulator, and the adaptive grid made the appropriate adjustments for the form factor that it found. And it's things like that that remind me that when you're building something for current devices with modern tooling, you can take away a lot of the complexity and pain. We didn't need to think about what type of device are we building for, how is it configured, which systems do I need up and running. Admittedly, I was on a Mac, I had Xcode installed, so some of the overheads were taken care of for me. But my code is now working on those. That is just rendering an app, well, it's building an interactive application, but it didn't work with some of the other strengths of Go, like unit testing, I hear you say. So we could, in fact, unit test our graphical application. People have told me that's impossible before. I know that they know that that's not really true, but it can be very difficult indeed. But we're going to use the standard test package with Go and write a unit test. Actually, that said, I'm going to use Stretchify's Stretchers testify assert, which I find to be really useful. Hopefully there's nothing particularly surprising here. We open a test case function, and inside it, what we're going to be using is our widgets disconnected from any graphical context. So we create a new entry here, and then we use our test package to simulate typing. That's not essential. It's just a helpful utility that allows you to kind of have the mindset of a developer on your platform. And then we assert that the content of the entry, the text inside it, equals the text that was typed. Yeah, okay, that's pretty useful. You might expect that that is the case. You can then do things like double tapping the user interface. So in this case, we just use another helper from the test package, say double tap, and then we're able to assert that the selected text is in fact the same content. It has selected the entirety of the text in the widget, and we can make sure that that's worked correctly, and we can check that the cursor has progressed to the end of the widget. But what's actually really cool about this, not only is it going to run as a unit test and super fast, it's going to do that by not having to render anything to your screen. It's not going to take the keyboard and mouse control away from you for the period of time it's running. And because of that, it's running basically at regular unit testing speed. So you can have thousands of these in your application suite without trouble. If you think, but it's graphical, I really want to test the graphical output, that's not a problem either. The test package allows you to assert that you're rendering, that your application renders to a certain look, a certain combination of pixels, or that your widgets have an object graph, so you could check the state of an entire application against an XML golden file as well. Not going to get into demos of all of that, but suffice to say it runs super fast as well because it's not doing any rendering. It uses internally a software driver to render to those pixels if required. Happens to be the same software driver that people have used in their industrial components because when you're pushing pixels to frame buffer, that's all you need to work with. So we've coded an app, but it's still just a binary on the system. We've run it, and that's great, but we can't so much distribute it. So packaging is where we need to go next. There's a helpful command line tool called Fine. Yeah, I'm really good at naming. That you can go install from that URL, and it's going to drop that onto your Go path. If it doesn't, if this command doesn't do anything the first time you try, just check that your user's path has your Go path in it as well, or the bin packet, bin folder from your Go path. There's an FAQ about it because for some reason not all Go installers set it up correctly. Then we can run find package. That's going to create a bundled piece of software that looks like any other graphical application distributed for the current platform. So on Windows, this will still just be an .exe file, but there'll be an icon there. For Mac, it might be a .app bundle, and various other platforms have lots of other formats. If you're developing locally, you probably actually just want to install it on your system. So you could type find install. It's going to do the package and then drop it into the system standard location. So /applications on a Mac. If it's Windows, buried somewhere in your C drive, but it will drop a start menu item into your user's configuration. Pretty helpful when you're developing for yourself. But one of the reasons we package is to be able to distribute it to other people. So we're going to put, we support wrapping and the cross-compiling functionality with this packaging as well. So on my Mac, I could say, build a package for Windows, and it will spit out the .exe file. And then we can similarly install it across different platforms. Here, setting up the Android build, and it will push it onto my locally connected Android device. I need to give it an ID because mobile apps, they're a bit sandboxed. They want to know who you uniquely are, and that leads into some complexity with approval at stores, but I'll come to that in a second. I mentioned I would come back to the complexity of cross-compiling. You can manage your own tool chains if you want absolute control over this stuff, but if actually you just want it to work and you don't mind having Docker or Podman installed on your platform, you can use FineCross, and that's going to take away all of the complexity. It's going to download an image from your laptop, from the internet to your laptop, and run the developer tool in a container, spit out the binary or the package, and then shut that container down. And I heard that worked pretty well for people who joined the hackathon yesterday, so it's pretty convenient. Anyway, you should end up with something like this. You've got some source code, an icon file, and your metadata. And here you can see I have built this Markdown app for Android, for my Mac, and for a Windows computer. And these files can be shared. They're mostly statically linked, or they only use operating system dependencies, so you can share this with your mates. But that's not how you get things out onto stores. You actually need to release the software in a different mode. And so we added a release subcommand as well. So some platforms will require this app ID that I showed you before. On my Mac, this will have created a system package that I could upload to Apple's store for Mac distribution. I could do the same with iOS, as long as I've got Apple's approval to distribute under this profile and certificate. Or Android with a key store. Hopefully these things mean something if you're developed for those platforms before. If not, I'll come back to a way that we can improve that. If this long list of commands that we've used as parameters to the find package sounds a little bit confusing, you can use fineapp.toml, a little piece of text that saves a lot of it locally, so you don't have to remember the parameters that have been sent in. So that's how we do things, how easy it is. It really is that straightforward to get something onto all of your different devices. But I wanted to whiz through a little bit of what actually else can be done. There's, as you would expect, a bunch of graphical capabilities. We could do lines, rounded rectangles, circles, text, more. All of these components are vector graphics. It's going to scale appropriately for the device it's running on, so you always have super sharp output. We do support bitmap images, so you can use them. I would advise against it if you want the really best output, but if you're going to use them, just be aware that we're working with vectors, and bitmaps don't have an innate size in the way that you think they do if you're used to working with pixels. So coming back to containers, make sure that you give your bitmap image space that you want it to occupy, or it might be super small or fill, depending on the default that you've used. And we also bundle a lot of the material icon, the material design icon set, and standard themes for light and dark. So your applications are going to look really delightful out of the box. We have a lot of widgets, as you might expect. These are all created using a one-liner. The constructor function is going to take the necessary parameters so that you don't have to worry about which configuration do you need, how do you add things later. So we could create a label or a button, progress bar, rich text. You've seen some of these already, and every single one of them is just a single line of code, and you can pass that into the container. So you've got really succinct code for your complex app, and a bunch of other things like toolbars, separators, accordions. We can handle a lot of input as well. In the same way, a single line constructor is going to take any required parameters. Entry, for example, doesn't have any, or password entry. We can slide between certain values, and there's different configuration there. The checkbox, the group, the radio group, there's a check group as well, or a drop-down select item. And once again, there's others. We have select entry and form. All of these widgets allow some configuration, but set it up with the default constructor, and your code's going to be really easy to read right away. And then you can look at the extra fields exposed by each of these widgets, the constructors, as you might expect. Return the widget type. Looking into slightly more complex stuff, large amounts of data can be a challenge when you're rendering to screen. You don't want to have to draw everything just to know which bit is visible on screen. So we added the concept of collection widgets. This list, for example, it takes 3 callbacks so that your application can manage data, the toolkit can render it efficiently. So we ask you how many items are going to be in this list. And then we say, the second function here is a template. What is your list item generally going to be looking like? How's it constructed? Because we're going to want to cache a bunch of those and then apply your data into them as the user scrolls. So the last callback there is please apply the data for this row to a cached object. That might be familiar to people who have used AppKit or UIKit from Apple before. I think some of the Android widgets do something similar as well. But this means that people can scroll and scroll and scroll through thousands and thousands of items really fast on any device. And that's what a list looks like. And also we have a table with optional headers, a tree, and a recent addition of a grid wrap, so things like file dialogues. And a bunch of containers as well. You could do splits, application level tabs, tabs for documents. You can put anything that you want into a scroll, or could create your own container using either one of the standard layouts or one that you've invented yourself if you think that what we have isn't quite going to meet your needs. There's also a bunch of helpful dialogues. For example, this one here, again, a one line is going to set up and show a dialogue over the window that you specify. This takes a Boolean callback so that you could decide on the path to take based on the user's result. You can ask for more complex input. You could show them some information. There's even a show error if you literally just go, this is a user-facing problem. I can't handle the error. Show it to them instead. And a really nice color picker. One last one here, and it's sort of a technical concept to round out the capabilities section a little bit, is the file dialog for opening and saving files and folders. This is something that I would say if you're building an application for platform agnostic or even across multiple platforms, don't use the standard I/O or FS packages. You're going to make assumptions about the file system that might not hold true. So instead, this little code snippet here is for opening a file. It's fairly straightforward. It takes a callback function that's passed into show file open. So we're choosing which file we want to open. Firstly, we're going to see if there was an error. And if there was, well, we're just going to present that to the user because it was probably due to something they did. They picked a drive that had gone offline or a file that didn't match. And then we check if the reader that was returned is nil, because the user could have changed their mind and they didn't select anything at all. So well done, Go, on the helpful, not verbose, error handling. At that point, we're going to want to read the stream of data that was found. So we use read all, and in this instance, I'm just putting it into a text editor. We've opened a text file. I want to show the content in an entry, and then I'm going to save the URI for later. So think about URI, of course, like a URL or a file path. It's uniquely identifying where the data came from, and we might need to know that for later. Now that seems perhaps like a lot of work. There's standard packages in Go that can do some of this for us. Why would we do it that way? Well, because apps don't always behave like you would expect. This is a screenshot of the text open running on my iOS device. I didn't actually want to open a text file from my file system. There aren't any things there. I'm running in a sandbox. I wanted to pull the data from Dropbox. So by doing the code like I showed, it's going to open the system standard picker, and I can navigate to my Dropbox folder and open a text file directly from there. And as you might guess, there was no file actually behind that. It was just a data stream. There are plenty other things as well. If you want to get into system specifics, there's, well, not necessarily system specific, but you can add menus to your windows. On desktop platforms, you can open a system tray menu. You would check that your application instance is a desktop instance. I can get into the details later with anybody who's interested in finding more about that. We have a rich data binding package. So the example I gave you quickly connected one component to another, but sometimes you want to connect to an external system and you don't want to leak information about your UI. So you can use data binding to abstract that. You can have a string or a list of integers or something like that that's going to be passed through without having to share too much about how your application works. And there is a fine demo application, similarly in our repository, where you can see just about everything that's built into the toolkit. But it's not even limited there. The components, the widgets that are built with Fine are just structs from Go. They could be used in any application. You just import the package, call the constructor like I showed you, and you're going to use a widget from an external source with no thought about how was it coded, all those things. So we're using the strength of the Go distribution and the repositories there. You could drop a map into your app using the FineX repository map widget. Or, in fact, this one is a terminal, because an interactive terminal is a widget of the terminal project. Here I have an SSH terminal. You can see it's running on an iOS simulator, which doesn't have a user shell. So I've connected to a remote system and used the terminal widget to be able to drop that functionality into my app. Oh. There's really so much that's possible with something like this, and it is as straightforward as I've illustrated. A lot of people have done some pretty exciting things. If you go to apps.find.io, you'll see over 100 open source applications that people have asked to share. There's a lot more out there, but these are the ones that people are excited to be allowing everybody to download. And so you can look at them, learn from them, and adapt them if you would like. There is also a full operating system where everything graphical has been built with the Find toolkit. Everything on screen there, including the app installer, the desktop environment, that's all built using Find projects, including actually a Qt login manager, so you can have everything visual built on top of this system. The capabilities are all there. If you're interested a little bit more in app development, then perhaps this project is going to be interesting to you. A product called Fission, which has been recently developed. There's a bit of open source work going on. The full product will be available to test later this month. You can find out more at fission.app if you're interested. But this is a full-blown graphical application builder, so you can learn Go whilst you build your application, instead of having to learn the programming language so that you can build the application of your dreams. And just to show that this presentation is absolutely up to date, as if we're working on it and it'll be ready in 2 weeks, wasn't cutting edge enough, I have a slide here hot off the GoLab press. So I hope that Paul doesn't mind if I show this. But at the hackathon yesterday, it was suggested that the GoLab conference could have an app that allows you to browse what's happening and favorite the things that you wanted to go to. And in around 90 minutes, I think, somebody who'd never coded this before created the application that you see running on my Android phone there. It's accessed the data, it's loaded it into widgets inside of an accordion, and it's using some local user preference storage that's provided by the toolkit as well to remember what you have favorited in the schedule. And on the left-hand side is apologetic for the promotion FindLabs product that will help you to distribute your applications across all of the platforms that you desire, essentially. So when Paul sent me a link for where he had open sourced this project, I put that into our platform and said, I would like you to build this, please, for Android, for Mac, for Linux, for Windows, and it generated this page for me. The QR code does work, but perhaps it's a bit far away for you right now. So if you want to yeah, it works. Oh, fantastic. There you go. So you too can have a GoLab app that was coded last night over an hour and a half whilst we chatted and enjoyed the evening. And if you want to learn more about distribution, of course, FindLabs will be only too happy to tell you more about how they can help your business to do more in platform-agnostic app development with Go. So where can you find more? I'm going to be here all day and most of tomorrow, so I'd be happy to chat or answer questions. But of course, there's plenty of documentation online. You can go to developer.find.io. That is basically where you'll find most of our content. And on YouTube as well. We have a channel where there's some fairly recent tutorials, but also FindConf was 2 weeks ago, and the presentations have all been uploaded in advance of the conference today. You can read, if that's your thing, building cross-platform GUI applications with Find, available from the publisher, from other online retailers, or some of your favorite bookstores on the high street. Whether they stock it, actually, I couldn't tell you, but they list it in their catalogs. We're always looking to welcome new contributors to the project, whether you want to code, test, design, document, or really just be part of helping to promote the project. We're looking for people in translation and advocacy as well. Everything we do is based on GitHub. All of the websites that you see are open source, and the repositories are available for contribution. And of course, please do consider sponsoring the project as well. It's what makes it possible to do what we do, to get the contributors together like we did earlier in the month, and to get people out to conferences, although I must say that GoLab has been fantastic in supporting me to come here today, as well as other speakers as well. Thank you very much indeed. I hope that I have inspired you a little bit as to how Go is a great match for building graphical applications despite not being designed for it. I still get that daily joy when I realize how simple something can be to pull together, and I'd be more than happy to show that to people, to help build the applications that you want to, or to answer any questions that you might have. Thank you.
All right, thank you so much, Mr. Williams, for this very interesting speech. So now let's give some space to your questions. Anyone who has a question? Yeah.
That was a fine talk, Andrew.
Thank you very much.
I had a question about component libraries. So one challenge that some companies have is to ensure a consistent look and feel across multiple products. And they refactor their common styling into a library that's imported by the web app, for example. What's the recommendation for fine apps in this case?
So in a way, it's actually split into two separate components, which might seem a little bit peculiar because you described a component library. But in terms of application development, I think there's two different parts to that. There's standardized components that you might want to have that are reusable in your application. And there is how your applications should look. And the decision that we took really early on was to separate those two things, because reusable components is super important, but having your software look like you think it should matters as well. And so things are more reusable than they are in web components because we've made the separation. So much like I showed with the FineX repository or any widget that you choose to put under an available repository. I was about to say open source. Doesn't have to be. You could use private proprietary code in exactly the same way as long as you have access to the source code. So you can import widgets from anywhere into your application, and how they look is going to depend on the theme that is loaded into the application. What I showed you in almost all of the images was the standard theme. The yellowy brown Notes app was, of course, different. That was using a theme that was written specifically for how a Notes app should look. But the theme will default to what it finds on the system, and then it will look at what the application developers preferred. So yeah, the Notes app, I think, should be yellow. I might say everything that my company does needs to have highlights in orange and purple. So my app can say we're an orange and purple branded app. But also the user can override with their own preference to say, I want everything to be, muted or high contrast. And that's going to override the system preference. So you've got multiple levels of how things should look so that your end user is always going to get a consistent look and feel for the software that you build. And so in that way, you can pull application components in, and you could specify how they look completely separately, but you're going to get a consistent look to your software. Cool.
Any other question?
My question also goes towards theming, and so for Android and iOS, at least for iOS, there are like quite strict guidelines how an app should look. How easy is it to make an app that really looks like a native iOS app, like using iOS icons and iOS, I don't know, shading and padding and whatever?
Yeah, indeed. So it's an interesting thought as to what native should be. I would challenge anybody who thinks they know what iOS components look like to open up a brand new iPhone and pick 10 apps at random and see if any 2 of them are the same. And this is, in part, is to defend a position that I have, which is that consistency is more important than absolute rigor application of a standardized widget set. Because we've moved to a sort of a flat but with images and highlights kind of place now where the widget components aren't what you recognize an application with. So the consistent approach that we take is that it's going to work equally well on all devices. Now, what this means is we're taking the pain of making sure it does work on everything. So if you have a fine app that you've built, you know that it's going to be able to be uploaded to the iOS store and be distributed without hitting any of the red flags, because we've avoided them over painful years of experience, both with this technology and previous technologies, learning what is and isn't a good thing to do or acceptable according to guidelines. Now, in terms of standard icons, we have gone with the material set built in. You can either use that because it works great, or you can drop your own in. So you can have a custom theme that pulls icons in from elsewhere. So I suppose I should have said a theme is going to govern how things are colored, sized, the typography, and the icon set that are used. So you can override this yourself and delegate to system icons. I would be hesitant because that's where people get into the most trouble. Apple says this icon can only ever be used for this function. And if you have a slightly different function, but you use the same icon, they're going to reject your application. That said, there's certain things like sharing where the intent is absolutely clear and it must be consistent. We haven't got that high level into the toolkit just now, but the expectation is if you say, I want to share something, then it's going to use the system indicator or hint or integration to do exactly the right thing. So where it matters, the ambition is that we've taken care of it for you, and by using the standard theme or extending it in the usual way, it's going to be acceptable by all of the platforms and well within users' expectations. But you can do specific things if you want to. We just hold up a little disclaimer that says if you're going to override some of these things, make sure that you're not doing something unadvisable. But there's, like I said, there's a community out there that's happy to advise on all of these things as well. Hope that helps.
Any other question? No? Okay. Well, I guess Mr. Williams will be available anyway during the day, throughout the day, in case you have any other question. So, okay. Thank you so much for your speech today. Let's applaud again.